Hello, my name is Graham and I'm here today to show you the signal I built for the Orchard Wharf layout. This is the kit we will be building. It is an LNER upper quadrant tubular post signal and we will be building it with a 20-foot height for the yard. These are the bits that come with the kit, and as you can see I'm going to use DCC Concepts LNER white loco lamps for the illumination. We're using white because there's a lot of bleed through light on the lamp, and if we paint it black that'll block it out. These are pictures of the finished brass signal. Unfortunately, when we started to build this we didn't even consider about making a video. Therefore, unfortunately, we don't have any pictures to show you how we built it. The signal was masked for painting and a cocktail stick used as a handle to assist whilst we were applying the Humbrol acrylic spray primer. After the primer was done, the LED was then fitted. Final painting, again using Humbrol paints, this time acrylic. Satin paints. This was then covered with a black wash and DCC Concepts weathering powders applied, and everything then sealed using a satin varnish. For mounting the signal to the baseboard we shall be using a MERG Semaphore signal removable single mount. This consists of the actual mount itself, the removable components, resistors and diodes, and the finished device should look like. Under the baseboard we have the servo mount, and you can see on that mount we have a resistor to bring the voltage down for the LED, and also a diode to protect it. The diode is not strictly necessary, but if the LED becomes damaged, basically it's near on impossible to replace. It would mean scrapping the signal. Therefore there's a reverse current diode to protect it just in case. You may notice there's some cork underneath the servo mount. The reason for this is the servo mount is either 6mm or 12mm baseboard thickness. On Orchard Wharf we're using a 6mm baseboard with 3mm cork, which gives us 9mm. So we've used 3mm of cork underneath the servo mount just to give us that 12mm spacing. These are the test boards that Orchard Wharf is using to test the electronics before they are installed on the layout. The electronics we are using for the accessory bus is based upon MERG components. The accessory bus drives the points, the signals, the building lighting and any other servos independently of the DCC. To test the signal we have a control panel. The control panel is connected to a device called a CAN-PAN. The CAN-PAN is the panel controller, and from here a signal is sent on 2 wires to an MIO out, which produces a digital output which is used to drive a Megapoints controller. We are using the Megapoints controller to obtain the signal bounce. Here we're showing a servo with about a 45-degree angle, which is connected to the Megapoints controller, and this is just to show the bounce at 45 degrees. As we can see, the bounce is quite nice and it is not overshooting at all. However, what we have found, and we'll show you this later when we show you the final signal, when the angle is less than 45 degrees, the Megapoints controller doesn't perform as well on signals with bounce. This is the finished signal. And as you can see, with the smaller travel required for the MSE signal, the bounce is not as good as it is with the 45 degree travel which we showed you earlier. Having said that, it still looks good. I am pleased with the result, and hopefully other people from the layout will also be pleased. Also, you can see on here now, one of the advantages of the Megapoints controller is every action of the signal is different. I hope you found this video enjoyable, and hopefully some parts were of interest for your layout. In the future, we hope to do more videos on small projects we do for this layout, and so until then, thank you for watching and goodbye.